And from now onwards we will be switching to the programming part altogether. So let's say some of the fundamental things of C# programming. I will first give a brief introduction to what is value type and what is reference type. Then today we will see what are generics. We will see the delegates, and then in the other classes we will see the other part. We are all familiar with what is a value type and what is a reference type. So a value type is nothing but a type of variables that you are familiar with in your Java programming language. That is the variables that holds the value directly. Inside them are value types. Whereas the reference types are the type of variables that does not hold the value, but they point to the location where you can find the values. So that is the reference type. They are similar to the reference type in Java, whereas the value types are similar to the primitive types that you see in Java. C# also supports the pointer types, but if you are using pointers, then you have to make the code, you have to mark that particular section of the code as unsafe, and when you mark it, the common language runtime will not bother about handling that section of the code. In other words, the pointers will run on a native thread, whereas the other part of your program will run directly. So I'm not going to venture into pointers anymore because it's not directly executable inside a .NET environment. Now let's look at the different types that you get in the .NET. We have the value types and all your primitive data types that you see, the boolean, the int, the short, and all of them, they all belong to this value type. Apart from that, we can also get two other types. One is the enumeration and the other one is the structure. They also belong to the value type. When we say value type, the values are stored inside stack. Whereas when we talk about the reference types, the values are stored on a heap and a pointer to the heap is made from the stack. So we have the reference type, which are classes, interfaces, arrays, and today we are going to see what are delegates, very different data types that you are not familiar maybe in it. Now this is what you get right at the top of the hierarchy. Everything starts with system.object. So all the things that you do in C#, the base object for all of them is system.object, and you notice here pointers are no longer considered. So the type is there, but it is not cannot be directly manipulated. From the object type, you can derive the other type. For example, you have from the system.object there is a derivation for system.string, system.array. Everything inherits from the object type. So you have system.delegate, which also gets inherited. Don't worry about the arrow here, but it's just a inheritance that is coming from there. Okay. Whatever data type that you create, that is whatever classes that you create, the employee, the student, and all those kind of classes that you create, they also implicitly inherit from the object data type. So there is every object that you create automatically inherits from the system.object. All the values type that you are creating, that is the double, boolean, int, whatever data type that you are thinking of using, they all inherit from system.value type. So there is a inheritance, implicit inheritance, and this system.value type in turn inherits from system.object. What does this mean? Unlike in Java, wherein you say that primitive types are not object oriented, in C# that is not true. Everything gets derived from the system.object. That means it's a 100% object oriented programming language. There is nothing called primitives or anything. Primitives are also something that is inherited from the system dot object. So from the system dot value type, you get this set. You also get the enumerations that you are thinking of using. So all your enumeration that you create will be inherited from system dot enum, and that enum in turn derives from the system dot value type. And there are other types. One is system dot nullable, which in turn derives from the system dot value. Also the user defined structure, whatever struct that you are creating, all of them in turn inherit from the value type. However, there is a distinction. When we talk about the value types, the implementation of C# is done in such a way that value types, even though they have the object, they are derived from the system dot object, they are not placed in the heap. Instead, they are placed in the stack. So when you create system dot int32, any object of that type, it is not going to be placed on the heap, rather it will be placed on the stack. So whatever that gets inherited out of this system dot value, they all will be placed on the stack. And when we say they are placed on the stack, the garbage collector usually will not bother about collecting anything from the stack. So it is only interested in the heap. So when I say garbage collector, why do I bring that word here is, when you have this garbage collection, there is an overhead that is involved in placing anything on a heap. When you say I want to place 1 byte on a heap, you will have to spend at least 4 bytes in order to place it on the stack. Even though your data value is 1 byte, additional bytes are required to hold it there. What are those additional bytes? Additional bytes involve at least one thing, that is a marker that says whether the object is in use or it can be garbage collected. Also, there are additional information as to which pointer that is pointing to and so on. There will be additional overhead. Whenever you place something on the heap, the overhead is more, not only to place it onto the heap as well as for the garbage collection and so on and so forth. So let's come back to the value type. Our value types that we are thinking of are all derived from the system dot object. You must remember that. So whatever you get is system dot system dot value. From there you get all the data types, integer, boolean, and all of them. And there is a subsection here that is the system dot enum, from which you get all the enumerations. Let's quickly go through what is the difference between both of them. When we talk about value types, they are stored in the garbage, they are stored in the stack, and there is no garbage collection. And the values are directly held by the variable. So what does this mean is, if you have a stack here, so if you create a stack, and if I create something like int x equal to 32, it simply means that this location in this stack holds the value 32. So values are directly contained in the reference. Whereas if I create a object, let's say student, std equal to new student, if I do this thing, then the std that is here does not contain the student object, rather it contains the reference to a object that is there in the heap. So it's just a pointer that is pointing to a object that is there in the heap. Okay. So remember that the reference type does not directly contain the value, whereas the value types, the one that we are talking about, directly contain the value, and they are placed in the stack. Okay. And the other one is, when I create the something like this, if I create int x equal to 10, int y equal to x, if I do that thing, then what will happen? So we have the stack here, isn't that this is the stack, and we have the x that is pointing, and the x has the direct value 10, and let's say we have the y here, and when I say x equal to y, what is happening is it is not pointing to the value 10 here, rather this 10 will be copied to this location. So what you get is the copy. Okay, so whenever you assign a value types, a copy of them is made and assigned. So we don't have a reference. Okay. Then let's look at the other type that we have not seen, but I expect you to do some study on these two things, that is struct and enumerations. The structure and the enumeration are all value types. So what's the meaning of that? If you create a struct and declare all the variables and so on, if you create a struct, not the class, that struct will be directly placed inside the, if you just create a variable of type say we create this one, I'm using that purposely, I'm using that thing. Okay, so if you create a std, that will be directly placed in the stack. So these values are directly placed on stack, not on the heap. So don't think that if I create a structure there will be a pointer from the stack to a heap where you will find that value. It is not true. Whether you create a structure or whether you create a enums, all of them will be placed in the stack. They are not placed in the heap because they are value types. Okay. There are some restrictions with the value type, and one of the restrictions are all value types are sealed. This is a different word for you. Sealed is a finalized class. Okay. You are familiar in the Java. What is the meaning of saying a finalized class? A class that cannot be extended anymore. The class, the life of the class is stopping there. You cannot inherit from that class. Such a class is called as a sealed class. We use the word sealed here. If a class is marked as a sealed, like if you mark a class as final in any of the Java class that you create, you cannot inherit from a finalized class. It cannot be extended. Okay. Whereas if you mark a class as sealed, it cannot be extended. So all your value types are sealed. That means you cannot derive one more object. So from the system.in32, I cannot do this. I cannot say a class myInt, and I cannot say it gets derived from int32. This is not allowed, because int32 is finalized. You can only use it, you cannot extend that int32. That's the meaning of saying that it is sealed. So you cannot inherit it. Okay. However, there is a way in which you can get the polymorphic behavior, and if you want to get the polymorphic behavior, that is true even in terms of your Java also. If you want that int, float and others to behave like a object, and if you want to take them into the polymorphic form, then you have to box them and then use it. So that's the same thing. Value types, even though they are somehow derived from the object, they are also object oriented part, but they are treated slightly differently by the compilers. So you cannot inherit it. If you want them, that kind of inheritance and all this kind of thing, what you have to do is you have to box it inside a object and then treat it like an object. So naturally, when you try to box it, you will have to spend some resource and some effort to get that value into a object wrapping and then put it onto the heap. So naturally, your overhead will be more. The one part that you must understand, which was not there in your C++ and not in the C, it was not there in your C, and that is a problem with the structure. Now, when you wrote the structures in C, the structures of C didn't have the functions defined inside it. You cannot define a function for a structure in C. It is not possible. Structure contains only the data definition. Whereas when it comes to the C#, structures can have function inside it. In fact, structures have their own constructors. There is a default constructor that is associated with a structure. This is slightly different from your old programming language, that is C. Also, a structure can implement a interface. A bit confusing, but it is possible. The other thing about value types is value types cannot hold a null reference. So what does this mean is, if you create int x, you can assign a value 10 here, but you cannot assign a value null to the int or anything. The reason is, int is placed in the stack, so naturally when I say x, I expect a integer type of value to be placed here, not a reference type, that is the null. So I cannot think of putting the null value here because it will violate it. However, there is a workaround for that, or we will see how to go about it. Now I have already told you, all of them are object oriented, so naturally there will be a constructor for all of them. These constructors are automatically created. So when you write int my int like this, it is same as writing this statement, student std. Now this statement just says that there is a pointer that can point to a student, but this pointer is not initialized. When you say int x, it also means similar to that, but it is a value type. This is not initialized. X is not initialized. So you cannot directly use the value x before initializing it. The compiler will stop you from going ahead. So if you want to do something, you can say that int value is equal to 0, or exclusively, nobody does this, there is an option for initializing the int. So I have created, say, int x here. I can say x is equal to new, a new operator, and then call the constructor. It is possible. It will initialize it with the default value. Okay. So let's go to the other type, and that is the problem of null. You cannot assign a value directly null to a value type because it is not allowing you to do that. Let me start a new project, so it will be much easier if you look at that, and it's going to take some time. So let me switch back. So if you want a null value to be placed on a value type, then you have to use the generic version, and that is the system.nullable. You have to make it nullable. Now this is generic. I think if you are not familiar with the word generic, you are familiar with the word called as template in C++. Okay, you've seen the power of the template in C++. Templates are, we don't call them as template here, we call them as generic. Okay, generic is nothing but a way in which you declare a template. Now what is the meaning of this? System.nullable of t. Nullable of t means t is a type that can be replaced by any data type. For example, I can say system.nullable of int, system.nullable of float, system.nullable of structure, but I cannot say system.nullable of student. It is not allowed because nullable works only with the value type, not the reference type. So it can be anything. Nullable of int, float, double, any value type is valid here. But if you give a reference type variable like student or any other employee or any other object, that class that you can think of, that is a reference type, this will raise an exception. Nobody uses this syntax. However, people use the shortened version of that syntax, and that is TN question mark. That means to say data type and a question mark. Let me see whether it has started something. Maybe it's going to take some time. Let me go back. So how do I create a nullable of int? Now in order to create a nullable of int, remember, if I say int I, this is not a nullable version. So that means to say that I can assign a value 10, I can assign a I value 20, but I can't assign a I value null. It is not possible because by default value types will not take the null value. What if you want the value types to take the null value? Then you have to make it nullable. How do I make it as nullable? A long way of doing it is just write system dot nullable of int. Okay, this is a very long way of doing it. A short way of doing it, int question mark, define the variable. So x is now nullable. That means to say that I can assign the value null to x. It just means that. Okay. So if you notice over here, again it does not mean that once I create this particular thing, I cannot assign a x a value 10. It is possible. I can assign a value. I can treat it like an integer. Apart from that, I can assign a value null to it. Now, you may be wondering why this kind of thing is required. This is required because sometimes what will happen is you are using a database. Oops. Most of the time you will be reading something from the database, and you are all familiar that when we talk about the database, when you try to retrieve something from the database, if the value is not there in a field of a database, suppose if you have a table here and you know very well, you take the primary key, let's say ID, ID I won't take it because ID cannot be null, let's say some numbers, you are storing some numbers in the field, in a field of a database, and if the number is there, some number is there, and when you retrieve it, let's say it is an integer type, when you retrieve it, you will get that integer value. If the number is not there, and if you ask the database to read it, it will return a null value. So it will say it's not there. This is the most common thing the database usually does it. Now, if you are assigning these values that you are retrieving from the database directly to a integer here, what will happen is when you read this 31 can be placed in the integer. For the second value, second field, when it tries to place it here, it will end up in an exception, runtime exception, saying that your C# program will crash altogether, saying that you are trying to place a null value into integer. I don't know how to place a null in the integer location. So this problem usually appears when you are writing any application that is connected to the database. So what's the workaround is make it nullable. So when you make it as nullable, it is possible you to place a null value directly into a value type. So let's look at how we can do that thing. So if I look at here, if I create a int x, and if I place this x here, and when I won't get it. Okay, just place F12. Let me try that. You notice here, I'm placing the cursor. At least you can see that int is not a class there. Int is a structure. Okay, you say struct system32. It's a structure that is defined. What is important is I told you structure has a method. So if you put a dot, you get some method here. This was not possible in your C. Suppose let's assume that in your C you created a structure called as student, and let's assume that you created a structure called as student. This is going to end up in a big trouble. Let me say that you created that particular thing. This is not the right way, right place to define something. And in C, I'm not, don't think that it is a C# now. In C, if you had student, you would have got something like student dot reg number. You might have used this kind of a notation where you said that reg number is a field within that structure and I can access the field and so on and so forth. However, when it comes to C#, there is a small variation. You can have a field within, you can have a method within a structure. That is why even though this x is a structure, you will notice that x has some methods automatically there. And you must always remember whether it is a structure, whether it's enumeration, they are all object type, they are all derived from the object. That means they have the base property of a object. What is the base property of an object? If you create something called as object obj equal to new object, is it possible? First of all, can you create this? Can I call a constructor like this? Yes or no? So obj dot, you see that the methods. One is there is a equals method, there is a toString method. That is why I told int, and last class I did double dot toString. And none of you just asked me how on earth that you created a double, and when you put a dot, you are able to convert directly on fly. You are able to convert it into a string. Whereas if you are using this Java, and if you had declared like this double x in Java, and if you had put x dot and toString in Java, if you try to do it, you will not get that option. Java will not say that the primitive types, there is nothing associated with the Java, whereas that's not the case in C#. Double or int or anything, they are all structure. Again, let me go here. You notice that it's system.structure. Okay, it is a kind of structure that they have derived. Okay, now let's go come back to the nullable type. I declare x and I assign the value 10 to x. It is perfectly valid. I say that x is equal to null, and if I go down here, or you will notice that it just the compiler on fly, it says I cannot convert a null to a value type. It's not possible. For me, it is not possible because it just says if you are not able to show the entire thing, the last part it says it's non-nullable. It's not possible to null this one. How do I make it go for a null? Is I just make it as nullable. Now there is no problem, except that it just says that x is not assigned a value. That's okay. Here you will notice that you will be able to assign a null value to even a integer, and this is what is the meaning of saying nullable. This is the common syntax that everybody uses. So if you find a question mark, now let me take this x here as an integer, and let me take a variable y just to make a comparison as to what is happening. So I'll just make y equal to null. That does not mean that I can't assign y equal to 20. It has entire behavior of a int, but it also accepts null. So when you make it as nullable, they are integer by default. Apart from that, it can accept a null value. So that is something different. Now let's look at the difference here. If I put a x dot, I get this two, compare, equals, get, hash, and so on and so forth. If I put the y, and if I put a dot here, I get some additional thing, and you notice additional thing is I get type. Get type is again default one. Get value or default, has value. These are properties, and a value. So you get some additional thing because it is not a int anymore. It is nullable of int. It is taken from the template system.nullable. Now, what is this has value and other things? Now, if you assign null a value, if you assign null, and if you just assign x equal to y, you will end up in a small problem. What's the problem? You notice over here, and that is you are saying that the y is not a direct int, and now you are taking a nullable of int and you are trying to place that value directly into x, which is the integer. So nullable int is placed in the int, and it just says I am not going to do it. I will not convert it implicitly into that. So what if you want the value of y? So if you want to get the value of y, you have to say get the value. So y dot value will return the value that is stored here. Now this looks perfectly alright, but if you try to run this particular program, I'm going to just say console dot read key, so that it is going to stop at a particular point. Okay. Now if you try to run this particular program at runtime, you will end up in a trouble. So I'll try to run this. Okay, and if it does it, should have given me a exception altogether. Notice it just went off, and you notice here that this is a runtime error, not a compile time error, because compiler will not be able to guess what value is there. What is the problem here was I assigned the null to the while. At runtime, I get that value and I am trying to place it over here, and it just say that I cannot handle this because nullable object must have a value in order to fetch the value. What is the meaning of that? What does it says? What is the meaning of that error message is it says that if you want to get a value from the nullable y, then y must have a implicit value. Apart from null, it must have any valid integer value, then only I will be able to fetch that value. So you can have any valid integer placed into y, then you can get it. If the value is null, then this thing is not going to fetch that value. It can fetch null, but it can fetch any integer value. So if I type a 500 here and if I run it, it's going to go perfect without any problem. There is nothing to be outputted here, so I'm not outputting. It's not going to create any runtime exception. Now, so at runtime, how can I get the value? So if I really don't know, somebody has given me this value y, nullable value from some side of the world, and I want to use it in my application. How do I get that thing? Now, if I just type the value and suppose if it was a null, I will end up in a runtime exception. Is there a workaround? The workaround is I can go get value or default. So what is this get value or default? Either get the value which is assigned to it, so whatever value that is assigned to it. If null is assigned, if there is no value is assigned, then give me the default value of the integer type. And you know very well default type of any numerical type is 0. So get the default integer value if the value is null. So that is the meaning. Either get the value if the y is assigned some value, integer, perfect integer value, get it. If you can't get that thing, if it is a null, convert it as int. I'm going to just write a CW here, and I'm going to just print the value of x. I will not give any decorations for that, and you will notice that the default integer value is 0, and it's able to give me that. So get or that. What is the next part? The next one is has value. It's a boolean value. Okay, it checks whether it has a value or not. For example, I can use this one. I can say if y has value, then this is the long way of writing. Assign x equal to y dot value. We'll do that. Else assign x some value, some default value that is applicable to your application. Okay. So this is has value will check whether the value is null or not. If this is null, then it does not have any value. It's going to assign this part. If it is not, if you want, you can just put a break here, then try to execute it. So we are here now, and you notice that y is having a value null here, and if I step into this one, if I step into that one, you notice that it is null here. This value is null. Okay, has value. If you notice here, the value of it is false. If I step into this, you notice that it is not taking the if part because it doesn't have a value. It's going to take the second part, and you can step over it. I will just stop it, and I'm going to assign a value, some integer value here, and let me rerun it again. And this time you notice y has a value because y is 24, not null. So this will be executed. It's going to go into this term. Okay, so that's simple as that. Now there is a shortcut for all these things, and the shortcut is you are putting y double question mark and default value. Equal should be there. I just need that equal. Okay. So what is this statement? Double question mark indicates. Double question mark indicates that if the y has a value, assign it to x. If y does not have a value, assign 180 to x. So it is that full if statement brought down into one line. So double question mark means either get the value or get the default. It's one in the same. So if in my case, if I put the x over here, I must get 24 here because y has the value. So if I quickly run this without stop, I'm going to get this 24. If I somehow assign null to this and then I try to do it, I must get 180 because if y does not have a value, it will use the, if it doesn't have a value, that is if it's null, it will use the other side. Okay, so let's go back to the, this I've explained all of them, so indirectly I've explained them. Again, you can use the y in the comparison, like not equal to, you can use all the operators with them. They are just the data types, that is the value types. You can use like a value type. Let's go to the next part, and that's a reference. Now, what is the difference between value type and the reference type? Reference type, there is a pointer that points to the actual location. So what is there in the stack is a pointer that can point to the other side of the word. Okay. So because it's a pointer, you know very well, pointer can be assigned a value null. So it is perfectly alright. So when it comes to the reference type, if I create assume that I've created student, std, I can say std equal to null. It is perfectly alright because what is a std after all? It's a pointer to some location on the heap. Okay, so it's as simple as that. Okay, a pointer can be null. You know very well. You can assign a null to a pointer. So there's no problem. Also, you must understand the other one is that if you create two pointers, let's say if you create two student. So let's say I create a student. Let's assume that there is a class student S1 and S2. Okay, and I'm going to say S1 equal to new student. What it's going to do is it's going to go to the isn't that this is your stack? This is the stack, and isn't that you have a heap here, somewhere you have a heap, and it's going to create a student object. When this is executed, it's going to create a student object here, and let me assume that this is S1, it's a pointer to S1, and it's going to point to that. Okay, as simple as that. You are just pointing to a location from the stack. Now, if I do S2 equal to S1, what's going to happen now? So isn't that this one next location is S2? Now what is happening is there is no copy. Instead, this pointer will be pointing to the same location. So there it, unlike in a previous case, compare it with the previous scenario where I told you that there were two integer values. So I told you that there is this int x and int y, and I said x equal to 10 and then I said y equal to x. What happened in that case? Suppose this was x and this is y. When I assign a value 10 to it, it became 10. When I assigned x to y, it was copying the value. So here it's not copying the value, it is making a copy of the pointer. So it just points to the same location. What is the problem with this? Suppose if you say s2 dot name equal to some new name, what will happen in this case is, isn't that it is in double quotes? Okay. What will happen is that name will be highlighted in this also as well as in the other one, because both of them are pointing to the same object. One of the pointer makes a change, it will be highlighted automatically onto the other. So that is the problem. So they don't copy the data, they just copy the copy the address. The other part is, because you are already familiar, when you have an object, all the things like inheritance, polymorphism, and so on and so forth for all the data types are equally valid here. So let's summarize this with this. variables that are stored in the value types are values. What is stored in the reference is reference type or the reference. Values are stored in stack. Reference is stored in heap. It can be initialized with this. Okay, what is this part? Null what? What is null? Null can be assigned. What is this if you put it like this? This is an integer, this is a boolean. What is this? It's a character. Okay, so it's not a string. There is a huge difference between putting it in double quotes. If you put it in double quotes, strings are value types, they are treated very different. I mean, strings are reference type. Then if you put double quotes, it is not belonging to the value type, it just belongs to the other type. You can assign nulls. Copies the value, copies the reference. This is the meaning of saying that. So you have a copy. If you try to do it with the string, it's going to get the references. Okay. Now a very quick run through to all the data types that you have. I'm not going to waste my time on this one. You have all the data types that is commonly available in almost all programming language. There is nothing new about them. But what is different is when I use the int in my program, I was using a alias name for the int32. This is the other name. So this has, it's like a shortcut. I have created in Unix and other things. Okay, this is the other name for int32. So if whether you say int or whether you say system.int32, they are same. Okay, this is the other name for it. Similarly, long, float and others, we usually don't use this. And in fact, when I went to the Visual Studio, you might have noticed when I clicked on this one, it was saying that it is some other things.